We're going to take a look at graphing quadratic functions today. A quadratic function is always in the form of something times x squared plus another number times x to the first plus a number all by itself with no variables. You need to make sure you always have a squared term for it to be quadratic. You may or may not have your x to the first term or your constant. Typically, the number in front of x squared is referred to as a. The number in front of your x to the first is b. Your number that's all by itself is c. The graph of a quadratic function is a parabola. You also have an axis of symmetry, which is in this case a vertical line that cuts your graph in half. That's always at the form or spot negative b over 2a. Since it's an axis of symmetry, meaning a line, it has to be a vertical line. It's x equals that. The x-coordinate of your vertex is always negative b over 2a. So let's take a look at that stuff for this particular problem here. In this case, we have our a being 1, our b being negative 3, and our c being negative 1. So to find the x-coordinate of our vertex in our axis of symmetry, we need to use that negative b over 2a. So we're going to go the opposite of b over 2 times a. So in other words, our x-coordinate of vertex is negative 1.5. At negative 1.5, then you want to choose 3 numbers on each side of that. Negative 1.5 would be here. Choose 3 numbers on the one side of it. Choose the next 3 numbers on the other side of it. I'm going to work with just integers. Then you want to take your negative 4, plug it into your equation for your x's. Take your negative 3, plug it in. Take your negative 2, plug it in, and so on. Then you want to go ahead and graph those. Graph these points. Remember, x tells you how far to go left and right. The f of x is your y, tells you how far to go up and down. When you plot all those points, you end up getting a graph that looks about like this. You also have your axis of symmetry, which is a vertical line that cuts your graph in half. Your axis of symmetry is the same as your x-coordinate of your vertex, but it always has to be x equals. So it's x equals negative 3 over 2. And whether you write that as negative 1.5 as a fraction or not is up to you. Here's your axis of symmetry. And so this is the graph of this parabola. So continuing on here, let's go ahead and find your y-intercept of this particular problem. Your y-intercept is when x is 0. So you plug in 0 for x up here, here, and simplify it, and then you end up getting 2 for your axis or your y-intercept. Finding your axis of symmetry, you need to find a, b, and c. Your a is what's in front of your squared term. Your b is what's in front of your x to the first power, and then your c is the term that's all by itself with no variables. Then you want to go ahead, take your a, b, and c, plugging it in here. Your a, once again, is your 1. Your b is your negative 4, plugging it in, simplifying it down, and you get 2. So your axis of symmetry is x equaling 2. That's the vertical line that would cut your graph in half right here. Also, the x-coordinate of your vertex is also 2. It's always the same as your axis of symmetry. So now, then you want to go ahead and make yourself a t-chart, choosing 3 values on each side of 2, taking each one of those values, taking negative 1, plugging it in here for x, taking 0, plugging it in, taking your 1, plugging it in, and so on. Then you want to go ahead and plot those points in your graph. Your first point's 1 to the left, 7 up. Your second point, 0 to the left, 2 up. Plot those points in your graph, plot all those. When you plot all those on your graph, you end up getting a graph that looks like this. Your axis of symmetry would be a vertical line right here at x equals 2, because that's the vertical line that cuts it in half, so each side of that black line is a mirror image of the other one. Your axis of symmetry is given to you right here. Your axis of symmetry, just like the x-coordinate of your vertex, helps you know where to start choosing your points. Now, if a, the number in front of your squared term, is less or greater than 0, then it opens up And if it opens up, it would have a bottom point, so it would have a minimum. If it is less than 0, it opens down and it would have a top point, so it would have a maximum. Your maximum or minimum is always the y-coordinate of your vertex. When your maximum occurs is always the x-coordinate. So let's take a look at this one here. We have our function. We know it does have a maximum since the number in front of your squared term is negative. But when does it have that maximum? Well, we know that it's going to have the maximum when we are dealing with the vertex. And you know the x-coordinate of your vertex is the negative b over 2a. So you need to go the opposite of 2 over 2 times your negative 1, because a is your negative 1. So you get negative 2 over negative 2, which is 1. So when does it occur is the x-coordinate of your vertex, and that's at 1. Well, to go ahead and find out what your maximum or minimum is, that's the y-coordinate of your vertex. So we need to take our x-coordinate of our vertex and just plug it in here and here. So we plug in 1, simplify it down, we get 1 plus 2, negative 1 plus 2 plus 3, so we get 4. So when does our maximum occur? When x is 1. What is your maximum? It's when your y value is 4.